Okay. Hi. My name is Zaid Abiles, and I'm a current freshman at Napa Valley College. And my current major is computer science. So, growing up, I've always been interested in the STEM field, especially the technology and engineering aspects of STEM. And so, when it came time to choose my major, I decided to choose computer science as I was as that was I guess fusion of both my major interests. And for this presentation, I'll be presenting calculus and its applications to computer science, as well as game development, as that is a future interest of mine. And it is also a branch of computer science. Okay, let's start with calculus. So for this course, we so for this course we covered calculus one, which is limits, derivatives, and integrals. For this, I'll be, for this presentation at least, I'll be diving into derivatives and their applications to computer science. Sorry. Okay. And computer science, for those of you that may or may not already know, computer science is a study of, well, computers and their computational, um, sorry, let me scroll down real quick, and the computational algorithms and applications. And computer science itself is an umbrella term. There's a whole bunch of different disciples you can go from computer science, such as cybersecurity, uh, product developer, software engineer, you know. So I'll be keep it a little bit general. But within computer science, you'll usually deal with programming languages, and within these languages, you have algorithms, data structures, and machine learning, which I'll dive into right now. So I'll be dealing with algorithms and optimization. Optimization is from calculus one, and algorithms are part of computer science. So real quick, for those of you that may or may not already know, I'll talk about algorithms real quick. So algorithms are a set of instructions or commands given to a computer in order to solve a problem and have a create a solution. And for algorithms, there's different types of algorithms. As you can see here, there's divide and conquer algorithm, backtracking algorithm, sorting algorithm, all different types. It depends the kind of problem you're trying to solve, the algorithm you're using. Sorry. And on the left here, we have a neural network, which is a type of deep machine learning algorithm, which has elements of optimization from Calculus 1. So as you can see here, a neural network actually is based off the human mind, which I found fascinating, and the nerves within our mind and how they connect. So we have three layers: the input layer, hidden layer, and output layer. The input layer, you have an input, which can be one, two, three, four, a whole data set, doesn't matter. A hidden layer that you digest, the information gets digested, and an output layer in which the output is executed to. And now for optimization. So optimization is a concept for calculus one that deals with finding the global minimum and maximum values of a function. And also, local and absolute or global. So as you can see here in the graph, we have a local, sorry, a global maximum and a global minimum, as well as a local maximum and local minimum. Some graphs may have multiple local maximum minimum values, some may have none. It depends on the graph. But here we can see that it has at least one of each element or type. And how we find these values are from a function we find at its derivative. If derivative of a function, we can find points at which it is equal to zero, or it is discontinuous or does not exist. And by sorry, let me drink. Sorry. There we go. And by taking sorry, my fault. I'll continue on. In its application. So optimization is used in training machine learning, as we seen earlier with the neural network. This is utilized for machine learning. So, for example, let's say we're training an algorithm to discern a cat from a dog or a car from a bike, and we're in its training phase. So, as the algorithm begins to learn how to tell apart these two, there obviously be some error, and this error is a loss function. So, with the cat and dog example, there will be some times where the algorithm messes up and the predicted output does not match the actual output. So, it might pretend or might say, or my output, a cat when it is being asked which ones are the dogs, and that would be a loss function. With the loss function, we are able to calculate kind of the margin of error, and with this long loss function, and the margin of error is yeah, and with the loss function, it also goes into gradient descent, which is down here, and this is the loss function up here. So gradient descent, essentially, we're trying to calculate the gradient descent is the absolute minimum parameter you need the absolute minimum parameter you need to minimize the loss function, which sounds kind of familiar. It's because it's optimization, as you can see from this graph. So trying to find the value that gives you the least amount of loss percentage from the loss function, which in simple terms just means that we're trying to find um or we're trying to not try we're trying to make the algorithm as efficient and accurate as possible. And next I'll go into video game development and rates of change, which are part of calculus, sorry, and computer science. So rate of change. So rate of change of so to start off, we're gonna have. Let me scroll down. Okay. So we have displacement as seen here. So displacement is the distance an object has moved from the starting point to an endpoint. So the video games can refer to a character moving from one spot to another spot. And for example, Minecraft, Steve running from one block to another block. And that'll be displacement. But with that displacement and calculus, we're able to find out the velocity and acceleration. So as seen here. So velocity is actually the derivative of displacement. And what velocity is essentially the rate of change of an object's position with respect to time. And if velocity is known, also able to find acceleration. Let me scroll down. Okay. And acceleration is the second derivative of displacement. And it is how fast velocity is changing with respect to time. This is important, especially in modeling how video game characters move, especially if the video games are realistic. And just for this example, we have Xenoblade Chronicles 2 and Minecraft. From Xenoblade Chronicles 2, we can see that the characters are moving from one spot to another spot. From our view, it just seems like they're moving, which, well, they are. But if we're taking the calculus and we're taking all the algorithms and all those, everything working in the background is quite complex. But using calculus, you're able to solve for the displacement, velocity of the characters, how fast they should be moving, and total acceleration of how fast their velocity should be changing within that. Sorry. Within that given interval. And as a quick note, I am not an expert yet on computer science, calculus, or video game development, but I will be. So for the time being, I do apologize if there's any errors or mistakes or forgot anything wrong. And I do thank you for watching my presentation. And in the description, I'll be providing a works cited to show where I got my work from, and also just to show where I got all these images from. And yeah, so thank you.